Hello, everybody. It is now 12:03, and I think we're going to start today's webinar. So hello and welcome to today's webinar. My name is Eric Bidmanis. I'm the Program Manager of Private Sector Innovation here at Canary. Might as well turn my video on too. That could be more fun. We will be recording this webinar and presentation, and it will be available on YouTube shortly after the webinar concludes. The PowerPoint slides of today's webinar were sent out ahead of time, so if you have them in your email, please feel free to follow along. And if you'd like to ask a question during the presentation, please use the Q&A option here in Zoom. You'll see that along the bottom or just along the tooltip bar along the bottom. You can also use the chat, but the Q&A section would be, we're going to see that, or that's the one we're monitoring more closely. We also have a couple spots in the presentation where we will address questions, so feel free to write the questions in the QA panel at any time, and we'll get to them during those periods. And now I'd like to pass it over to my colleague Annie to do our French introduction. Annie, please take it away.
Merci Eric. Bonjour à tous et bienvenue à notre webinaire du jour. Mon nom est Annie Gélica, je suis spécialiste en prestation de services chez Canary. Juste avant de débuter, simplement pour vous aviser que le webinaire est enregistré et va être disponible peu de temps après la fin du webinaire. Également, vous devriez avoir reçu une copie de la présentation par courriel, donc vous pouvez suivre avec votre propre copie si vous le souhaitez. À tout moment durant la présentation, si vous avez des questions, simplement les inclure, cliquez sur le Q&A en bas de votre écran et les écrire. On va y répondre au moment opportun. Sur ce, bonne présentation. Je repasse la parole à Eric.
Thank you very much, Annie. Merci beaucoup. Now I'm going to quickly go over today's agenda, what we'll be looking at here. So we already just did the welcome. We're going to move quickly into the DAIR program updates and news before getting into what you're all here for today, which is the Combining Machine Learning with Geospatial Intelligence in the Cloud webinar, our booster pack with Rama, Hussam, and Leslie. And after that, we'll have a Q&A period with some closing remarks. So for DAIR, the DAIR program, of course, we have many new booster packs. We have the newest one we're talking about today, Combining Machine Learning with Geospatial Intelligence in the Cloud. We also have 3 others that have been released this year: Data Pipeline Automation, Automatic Static and Dynamic Application Security Testing, and Build Private Blockchain Networks on Hyperledger Fabric. All those can be found in the booster pack catalog on the Canary website. We also do have an exciting announcement that we're currently in the process of investigating bringing AWS services access to the DAIR Cloud. We do not have an ETA on when those services will be available, but we are working on it. So more on that in the coming months. Now I would like to pass it over to Rama, Hussam, and Leslie for Combining Machine Learning with Geospatial Intelligence in the Cloud. Please take it away.
Thanks, Eric. Hello, everyone. I think, can we pass the presentation to Rama so that he can put it up on the screen? Yes, great, thank you. And I'll share my video. Okay, so hello, everyone. I am Hussam Kanj, and I am a technology analyst lead with ESI. I have been with the company for over 2 years now, and my work is mostly focus on researching different ambient air sensor technologies and improving their performance through researching new calibration method that relies on AI and machine learning, which is the core technology, the core business of ESI. However, on the BoosterPack project, I was mostly on the management side, working with the technical team to make sure the work is progressing on time and coordinating with Tom, Eric, and Don. Before I hand it to the technical team, though, I would like to mention that while we were developing the booster pack, we also had Professor Mohammed Bakr from McMaster University with us, who offered great help with the AI development. Professor Mohammed Bakr actually is still with us, but unfortunately he is not able to make it to attend today. Okay, now I will hand it to the technical team, Leslie and Rama, to present themselves and go through the presentation. Thank you. Leslie, do you want to start?
Yes, thank you, Hussam. Let me turn on my camera. Hello, everyone. My name is Leslie Mills, and I'm the lead in research and development at Ecosystem Informatics. My main focus is embedded systems application development, but I do have a graduate degree in geospatial information technologies with a specialty in emergency and disaster management. On the BoosterPack, I worked on the server-side solution and automating the entire process. So that's the extent of my involvement in the BoosterPack. And I'm going to hand over again to Rama to continue. Thank you.
Thank you, Leslie. Hello, everyone. I'm Rama. I have been with Ecosystem Informatics for the past 3 years. My work at Ecosystem Informatics is around building the analytics suite and also around interfacing with the clients and getting requirements, etc., and building out new and more useful tools for the set of clients we have. Specifically with respect to the BoosterPack, I was involved in developing most of the sample solution while Leslie was looking at more of the automation and deployment side of things. So I'll walk you through a large part of the presentation and hand it back to Leslie at a later point in time to walk you through his bit. Sorry, I'm just trying to. Right. So before I get into the BoosterPack itself, I wanted to give a brief introduction about our company, Ecosystem Informatics, or ESI for short. So ESI is a smart environment monitoring company. We have developed our own proprietary hardware that measures environment factors like air quality, meteorological factors, etc., and pushes that data to a cloud, on top of which we built several analytics tools and suites, and which helps our end users get insights and actionables into several different areas, with primary focus being regulatory concerns, public health, and climate action. So we help primarily smart cities and industries look into these aspects of their own administration and management to help them do better in these aspects of climate action, public health, and regulatory concerns. So moving on, ESI a few years ago was in a space where we were still a very small business, but over the time we have built our capabilities around geospatial intelligence and machine learning, because these are the core of our business. And given that most data now is also of space, is temporal, which is time series, that automatically falls into the same larger umbrella of the sort of data that we use, and hence our capabilities and experience really built up in those areas. And we kind of looked back and felt that there was a gap in the market for a tool that would help small businesses leverage the usage of geospatial information. So right now such tools exist, but there are several blockers in place for small businesses to exploit or make the best use of these tools. And hence we kind of felt there was a gap in the market. And that is why we collaborated with the DAIR team to build out this BoosterPack. It felt like the collaboration was ideal in that we could use their platform to deploy and show this solution at scale, and while we use our own expertise to build out something very specific, which is a cloud-based platform for geospatial intelligence with some machine learning involved as well. Moving on, so I want to really look at what we felt was the gap in the market when we started building this out. So we kind of identified three major areas in this. The first one being financial costs. So by default, financial restrictions are a part of life for any small business and even larger businesses as well. So we felt that the current tools that were out in the market were either really expensive, or there was some sort of financial barrier that was in place, which was leading to smaller businesses not being able to use these tools. So we wanted to address that by building a sample solution that was completely open source so that it's zero cost and free to use. We also felt that the complexity of what was out there currently was high. And by complexity, we mean some of them were not customizable to specific needs. There would be a lot of trouble integrating these tools into existing platforms, etc. So we wanted to build out a solution that would be upgrade friendly, that would integrate easily with other components, and where each individual component of the solution itself would be upgradable so that it connects well with things already out there and with software already in place. And the third major issue that we identified was execution itself. There was a lot of capability in coding, but we felt that in the market, the gap was from taking what was built and then deploying things at scale. So people had trouble because there's a lot of complexity in the underlying IT infrastructure. There's a lot of confusion in how to take things to scale. So it would work well for a small set of customers, but once the customer set becomes bigger, solutions usually don't work or have a hard time working. And this was one of the other things that we wanted to solve while building out these applications. Moving on, so what happened from that instance was we went on designing a sample solution which we felt should address these, and we addressed the 3 issues that I put forth to you using these features that we built as part of the design and development of this sample solution itself. The first feature of the sample solution is that it is modular, and by modular I mean the solution itself is built from a smaller set of modules that work together to build out the solution in whole. The advantage of this was we could piece out, so it's essentially like a Lego build. So if you could remove one piece and then make that piece bigger or customize that specific piece according to need. So that was the idea in making the sample solution itself modular. We also wanted to make sure that the solution was upgrade friendly. So whatever we built, we made sure that it was something that was maintainable. It was something that could be upgraded for future use, future technologies, etc. A simple example of that is the user authentication process, which is part of the sample solution, uses a SQLite database, which is part of the tool itself, but that could be upgraded to connect to user authentication services like AWS Cognito, or a simple SQL database where user credentials are maintained, although that is a security risk. But again, the underlying essence is that we made sure that each of the pieces are upgrade friendly. We also wanted to make sure that the sample solution is deploy ready. So there are 2 aspects to this. We made sure that whatever smaller modules that we built out were built out with using the Docker technology. So Docker containers were built out. This essentially leads to that Docker image for the sample solution. It can be deployed anywhere. So that really helps with migration of the sample solution itself across different platforms, etc. But the collaboration with DAIR here really made this point hit the mark. Is the DAIR collaboration really made sure that our sample solution was deploy ready. Just the ability to orchestrate infrastructure with DAIR allowed us to build out automated scripts that would ease the deployment of the solution to the end user. And finally, we made sure that everything was open source. We made sure that everything we built was free to use. Of course, there are components in what we built that have enterprise versions as well with more features. But again, that is up to the end user to decide if they want to make that upgrade or not. Moving forward, I just want to take you through what the core design of the sample solution itself looks like. So what we are seeing on our screen is just a representation of how things sit in the sample solution. The sample solution itself is a Docker application that sits on cloud infrastructure, which is powered by DAIR in this case. And each of the services within the sample solution are present in their own Docker container. So the Mongo database is one Docker. And in this case, it's upgradable because I can just take out this instance of the Mongo database and then plug in another data storage technique here. And so the Mongo database in the sample solution is where all the data is stored. And sitting on top of it is the AI module, which accesses the data from the Mongo database. The AI module has the algorithms for the machine learning in this instance, and they interact with the front end through a REST API configuration. The front end itself is written with a Python library called Dash, which gives a lot of flexibility with front end development, and it is upgrade friendly as well. So the Dash front end has the tools that visualize the data that sits in the Mongo, and it also has interfaces where you can request AI processing from the AI module. And finally, the Nginx web server is sitting on top of the sample solution, making sure users can access the solution simply through a web browser. And at this point, I'd like to hand it over to Leslie to continue with how the application was deployed and essentially how it works. So this Leslie's part will lead logically into the demo itself. And yeah, Leslie, whenever you're ready.
Thank you, Rama. Hello again. So what we're looking at is the general server-side deployment of the structure of the BoosterPack. And at the core of it is the automation script. Now, we wanted this to be as user-friendly as possible. So the automation script accesses our repository, the official repository, and then also sets up the environment within the Ubuntu instance, which is hosted within the DAIR Cloud tenancy. Each instance, of course, has to be provisioned with an elastic IP, and the elastic IP gives the means by which client computers can access the server and interface with the BoosterPack and perform whatever operations that they need to perform for which the BoosterPack was designed for. Next slide. Okay, so the BoosterPack was designed for, or was developed for the AWS cloud infrastructure. And it's, as Rama pointed out, it's a very containerized application which deploys its core components. And there's a logical data flow between all the core components, between the AI Docker image, the Mongo database, which is the storage for the geo database or the geodata, and as well as the Nginx, which serves as the web server interface for which the BoosterPack users can actually interface with the application. So the principle for the automation process was to minimize the user input while also still maintaining some sort of leeway for them to be able to decide how much resources they want to allocate for their individual instances for the BoosterPack. And it was deployed using the Ubuntu 20.04. It's also compatible with Ubuntu 22.04. So in the future, when DAIR gives support to Ubuntu 20.04, our BoosterPack is still usable within that environment. Can we go to the next slide, please? So this is a sample of the automation script, and it's essentially a bash script which performs specific operations to set up the environment for the BoosterPack deployment. And the summary of it is that it installs all the dependencies, libraries, and packages. In this instance, our BoosterPack was developed primarily using Python 3, and also does the application launch. So the user doesn't have to manually launch the application once it's the environment is set up. The automation script does everything for you. And we'll go to slide 4. All right, so this is a summarized step of all the tasks that the script is executing. So there's the dependency installations, as I mentioned before. There's a Docker container setup and the permissions as well. Directory tree configuration for to tell the individual Docker components where they can find the data. So there's a data flow between all the individual components. There's also the repository code pull, and then the initialization of the application itself. So this is the 5-step process that is followed when we want to automate the deployment of the BoosterPack. Next slide. So at this point, I'm going to go through the process of setting up the application for our BoosterPack. And for this, you'll have to log into your DAIR. If you do have an account, you can follow closely. You can log into your DAIR account. I'm going to share my screen. Screen 2, share. Let me know if my screen is visible. Okay.
It is.
So, okay, thank you. So in order to launch our BoosterPack, you can log into your DAIR account. Then you go to your provisioning. From provisioning, you can click on the apps. The apps allow you to create your own applications within your own DAIR tenancy account. Then you go to the button add, and the add gives you the option of choosing a blueprint. You can type in the search bar, and you can type Ecosystem Informatics. You're going to see our template, our blueprint, and you can see that it's being deployed using AWS. You can click on it and you can hit the next button, and it's going to give you the app summary. And here you can give your app a name. So we can say BoosterPack Demo. And for the group, this is going to, of course, is going to be AWS because it's developed for AWS, and you can choose your default cloud settings. For the environment, we're going to select staging. So these are options that you can put in the user. It's arbitrary, so you can put it in as you go. You can hit the next button. And this brings you to the configuration of our instance. So you can come to Ubuntu, click on Ubuntu, and you can give your actual instance a name. So we can say Ubuntu instance demo. And the description, you can give it demonstration of ESI Booster Pack. For the cloud, of course, you're going to select the option available. And for the version, the Booster Pack is developed for Ubuntu version 20.04. It is also, as I mentioned, compatible with 22.04. So in the future, when DAIR gives support to 22.04, you can still deploy it within that layout. And for the plan, this is where the user, the Booster Pack user has a bit of leeway in selecting the kind of plan that they feel is most appropriate for their application. So if they have a very large data size that's going to require a lot of computation, you can choose either whatever resource intensive, whatever resources that you think is going to facilitate your Booster Pack deployment. So in this case, for demonstration purposes, I'm going to choose the T2 medium. And for the resource pool, of course, you're going to choose the VPC available to you. And then networks, you can choose any option available to you. For your security groups, of course, these options are set when you create your DAIR tenancy account, and you can select them as you go. And the other important thing about this is for the public IP, because your clients are going to be accessing the Booster Pack remotely on the server, you need to assign an elastic IP. The elastic IP is going to be the means by which you can access the Booster Pack application through your web browser. So you have to make sure that you've assigned an external IP. And then you come down to automation, and the automation is where you choose the workflow. The workflow, of course, is the automation script that we've developed, and you're going to select the Ecosystem's GIL box workflow. And that is going to be the setup for this instance that we're going to create, and then we can hit next. Now, after this, you can hit complete, and it's going to start initializing or provisioning your instance for the Booster Pack for your application as well. So when you click on the Booster Pack, because I said you need to have an elastic IP to access your application, you can go to the instances, and in this case, once the application has finished provisioning, you can, when you hit this instances, it's going to give you the parameters or the settings for your instance, where you're going to be able to access your elastic IP. I have actually created a secondary instance for this purpose. So when you click here, you can see that the summary of your application gives you the IP address, and you can use this IP address to access the application as it's deployed within your instance. So with this, I'm going to hand over to Rama again to give you a general demo of how the user can actually access and use the BoosterPack within their web interface. Rama?
Thank you, Leslie. I'm going to take you through the sample solution. I'm going to start by sharing my screen. So we are at the exact same place that Leslie left us. Am I showing my screen or is it still at the presentation?
Yes,
You are.
Okay. Sure. So we created a previous instance because it takes a few minutes for the instance to get created, and hence I'm gonna demo the instance we've already created. So like Leslie said, we can look at the instances, and I'm just gonna click on the summary for me to go into the summary of the instance itself. And now I have the IP address of this instance here. All I'm gonna do is just say go. And so what we now see is the front end of the sample solution, which is being hosted on the IP address here. So the Nginx web server, which is one of the module, is doing this hosting. So now with the user, I guess the next step is for the user to log in to the tool itself. We do have some authentication credentials here, which are already shared as part of the documentation of this BoosterPack. But at the same time, there is provision for users to create their own credentials within the SQLite database, which is again upgradable as well to another service. So I'm just gonna log in and take you through the sample solution. So once I hit login, I get a screen which is the front end for the sample solution tool that we've built. So this is a tool that can be used to analyze geospatial information data, and it also has some options to apply machine learning algorithms on the data. So to start off with, this is the place that any user would start, is to select a data set which has the data. To make users familiarize themselves with the interface easily, we've included a demo file in the solution itself. The demo file is going to be present in all instances of the sample solution. So once a user selects a file, a data set that they want to load, the user would hit load. So now the data is being accessed from the Mongo database, and we have now gotten the data and it is being visualized. So the data, I just want to give you a look into what the data here is in the demo file. So the demo file has data of bicycle trips in the city of Chicago, and each of the bubble you see on your screen is a location where bicycles can be hired, and the size and color of the bubble represents the volume of bicycle hires at that location. So what my data is doing is just simply visualizing that. And so my demo data has data over several days as well. So if I move the slider, I'm going to see that the bubble is now showing data for the date that I have on the slider itself. Now, the next step a user can do is delve more into analyzing this data. So I would start off with just clicking one bubble. So I'm going to start with Damon Avenue and Pierce. And once I click that bubble, on the right, I see data populated for that specific station over time. So this is how the volume of trips look like for that specific station over time. Now I understand that there are places where I'm saying variable 1 instead of trips. The reason being, we wanted to allow the sample solution to handle even generic non-bicycle trip data, and hence we allow the user to upload any file, but as long as it's in a specific format. And the way to see the format is just to hit download sample file. So I'm opening the sample file up. I'm not sure if you can see it. I'm going to share my screen once again. So this is how the sample file looks like. All a user needs to do
Rama,
is
we can't see it.
the Excel.
No, yeah, the Excel is not open yet.
Sorry.
You might need to unshare your
Do
screen
you
and then
see it
reshare
now?
it. We can see
Yes.
it. Thank you.
Thank you, Hussam. Again, the sample file looks like this. It just has a small number of fields. So a user would need to input latitude and longitude data, which form the basis of the geo-specific information. They would have to enter a variable one. In the case of the sample solution demo file, it's realistic. It's bicycle trips. It could be anything. So if we were looking at real estate data, probably variable one is the price. Lat long is where the house was, and a variable ID is a unique identifier for each row. And then a name is just the name that identifies that location or ID, and it doesn't have to be unique. And then we have a date on which the sale happened in this case. If it was, let's say, crime data, so this data would be variable one would then be number of crimes of some type at these locations on this date. So it's just that you could get your data in this format, and once you manage to do that, I'm sorry, I'm resharing. Once you manage to get data in the format that you want, you can just upload it into this sample solution, and instead of bicycle trips here, let's say real estate prices come up. So that is built in, and hence we require a specific format to be maintained. There is no other reason why. So I'll come back to what other analyses one can do with the sample solution. So I've taken you through clicking on a specific bubble and us seeing what information that bubble holds over time. So I'll come down to the AI options that are present in the sample solution. So the first one is a prediction, where we are able to predict future values, and the other is clustering, where we cluster locations depending on some descriptive measure of those clusters. So in this example, clustering, since we have only the volume of trips, clustering would end up, the algorithm would end up clustering these locations by volume. So as soon as I hit cluster, my algorithm is running in the background, and my output is visible here. So you can see that the light colored dots are all concentrated towards the center and the north areas of Chicago. So it looks like those are the high volume stations. And as we go out of the center of Chicago, you can see that the colors are changing. So there are low volume stations peppered across as you move out from the center. Is like an ad hoc analysis I can think of just by looking at the clustering visual. But what happened was, we essentially have a new level of insight into the data seen here, being visualized here, and grouping them together. So now an action can be taken on, okay, so I want to act on the set of high volume stations. So now you have that list. And so this is just a simple idea of what can be done post this is done. I'll also take you through what the prediction option looks like. So I'm gonna, just for the sake of it, click on another bubble. So now I have the data for that station. I'm just gonna say I want to predict the next 4 values. So because I've selected only a single bubble, my option automatically detects that I'd want to predict for a single location. Since the variable is a time series data, then by 4, I mean I want to predict the next 4 days of data in this case. If it was years, we would predict the next 4 years. If it was data that was minute by minute, we would predict the next 4 minutes, etc. So once I click predict single location, my algorithm is taking the data it has for those X days already and predicting the next 4 days. So as you can see, my bottom right is now updated with the predicted values, which are in red, and the blue are the actual, which is essentially a copy of the chart on the top. So my algorithm has predicted that the next 4 days would have these volumes. Now, of course, the algorithm may not be exact because there's only 25 days of data in this case. As you have more data, by definition, AI algorithms get better and better with more data to work with. And one last thing before I end this demo is the user also has ability to work further with the data. They just, they have the option to download whatever they're working with. So a simple download working data would get them the set of data that they are working with currently. So in case they applied any filters with time, etc., they would get the current working file. And as you can see, it's in the exact format of the sample file. I have a latitude, a longitude, a date, a variable ID, which is the name of, which is the ID for this station. And on this date, these were the number of trips. So that's what I can read because I know that it's bicycle trip data. But the point was the user has the ability to delve further into what they already have, and that we felt was a valuable option in the sample data set. I'm gonna end my demo, but
Rama,
yes, Hossam.
the map selection feature.
Oh, let me come back.
We'll have to come back, right?
While you're logging in there, Rama, we did have a question that came in during your presentation. The latitude and longitude format that you use, is that in DMS or decimals? I believe it's referring to the Excel sheet.
Yes, I believe it's in decimal, but there is it is decimal. I'm just gonna say it's decimal.
Okay, thank you.
Sure, I've loaded the demo data set. So coming back to my demo, we've just looked at how one would select a single point, but there are instances where, let's say I wanted to analyze all the stations in this particular box that I've drawn on the map. So the user has the ability to select this option. I'll come back to how I did that again. So there is a box select, a user just clicks on box select and then it's a mouse drag on the screen. So once I did that, the right side now, this chart now has accumulation of all the stations within this polygon that I drew on the map. And hence you can see that the trip counts are very high because it's a aggregation of all the trip counts within this box that I grew. And now you can also see that the front end recognizes that I'm not trying to predict or I'm not trying to analyze a single point. I'm trying to analyze multiple locations. So I can just, again, do like, okay, I want to predict the next 4 or 5 days. So now it's doing its magic, and we're going to come back with a similar output where we see what the predicted reading is for the next 5 days, assuming these are the readings that are actual. So with that, I think we have run through most of the major features of the demo. There are smaller little features that still exist that are part of the documentation and are described in full detail. So with that, we end the demo, and so I just wanted to share that now that we've seen the sample solution, we believe we built out a framework and we built out something that is easily integratable, and we wanted to build something that someone can use as is if required, or someone can take what we built, make it bigger, faster, stronger, better, customize it and suit it to their specific requirements. With that, I'd like to open the floor for any questions and any feedback.
Thank you very much there, Rama. That was a great presentation. And now, if anyone does have any questions, please use the QA panel found at the bottom of your Zoom screen, and we can answer those as those come in. While we wait for some, we do have a big question come in. So about predictions, curious about predictions, is there a minimum size for the actual data set so that the AI algorithm can predict future data points? Rama?
Yes. Sorry, I'm just. So there usually is a minimum that is described by the function or the algorithm itself. In this case, I believe the minimum is somewhere around, you need at least 10 data points for the algorithm to predict the next one. So if you had anything less than 10, the algorithm would say, I don't have enough to predict.
There is another answer here to be answered, is how accurate the algorithm is versus if the algorithm run. And there is a minimum number where the algorithm, the points is needed for the algorithm to run, but to get a good, accurate prediction, that's a different story. And usually, well, I mean, you would need to have a sizable data set so that you can basically predict.
Perfect. I hope that answers your question. If not, please do ask a follow-up in our Q&A panel down low. I got them coming in fast and furious here, so hope you guys are ready. Now, for the map layers, this person would like to know if you can confirm that the map layers supported pls.leaflet.
Yes, we did use leaflet, and any layers that are part of Mapbox can be supported and integrated into it.
Perfect. There we go. Thank you. And now, in terms of the prediction algorithm, can the prediction algorithm use more than one input data set? So we're looking at multiple data sets here.
I can answer this question. So probably I'm looking at it two ways. One is, as an example, I look at the clustering. So right now the clustering clustered based on just the volume, but if there were more descriptive data about each ID, then we can use all those to predict. I don't know if what is meant by more than one input data set here. I guess it means if you wanted to bring two different files and predict based on that. I'm not sure if that is really possible, because it would by default mess up the context for the algorithm. So maybe you could either merge before presenting it if it's similar data, and if it's different data, it's probably not something anyone would do.
Okay, thank you very much. We have another one. And so, the example that they're looking at for when merging data sets or multiple data sets,
I understand. Yeah.
is for,
So,
well, actually, the example I have is weather might influence the use of bicycles, is what they're saying.
Sure. Great. I love the example. It does influence the use of bicycles. So in this case, if we also had weather data as part of the data set, we could definitely use it as a factor for the algorithm. So the algorithm would pick up not just volume, it would also pick up weather and then work accordingly.
Now, besides volume, does the algorithm support time series? Probably read that incorrectly, but besides volume,
Yes.
does the algorithm support time series? I think we go. That's the one.
I'm not sure. I mean, I'm not sure what the question really means, but the prediction algorithm works on the basis that the data is time series, and hence it predicts the next X instances in the time series. With respect to the clustering, you can make it, you can build out the algorithm to take time series as one of the inputs. So days of the week or date itself could be an input to the clustering, but then you need data with over so many days for it to be meaningful.
Okay, thank you for all the questions that have been coming in. Please do keep them coming in here. I'm just going to steal the screen from you for a sec there, Rama.
Sure, no worries.
So as more questions come in, I just want to get to this point here about becoming a BoosterPack builder. So if today's presentation has inspired you to become a BoosterPack builder, some quick pieces of information regarding that is that we are looking for Canadian businesses with experience and expertise in specific emerging technologies, which are listed on our BoosterPack website, on the Canary website, canary.ca/cloud. And then you can navigate to the BoosterPack builder section there. and you will see a list of technologies that we are actively seeking. If you don't happen to see the technology that you'd like to bring a booster pack for on that list, still do feel free to submit an EOI. The benefits of becoming a booster pack builder are that we do pay $50,000 to become a booster pack builder, alongside helping promote the booster pack and your business that obviously you use to create it, and then the connections that you would get to new and potential partners and resources from that. So if you are interested in becoming a booster pack builder, please do apply with an expression of interest on our website. And if you have any more questions for Rama, Leslie, and Hussam here, please do use the Q&A panel below. I'm not seeing any new questions come in yet. I'll give it a couple more minutes here. Are there any, is there any last pieces of information that you, Rama, Leslie, or Hussam would like to tell our audience here today?
Well, maybe I'll just say a couple of things here. Just maybe one thing actually is that this booster pack is mostly built as a framework, and although it is deployable, deploy ready for someone to just take it and use it, modifying the AI algorithm or even the file format that the AI will take should not be difficult, because all the component that you need to deploy such an application on the cloud is there. You just have to work on that specific section that you would want to modify or change, and let it incorporate other features or other variables.
Okay, thank you very much, Hussam. We did have a question come in while we were speaking here. This person would like to know if this booster pack can be deployed with an existing SaaS application.
I wouldn't be able, Rama?
It does have the capability to integrate into, but I do believe there would be some level of human intervention required for it to be deployed into another app.
Okay, perfect. Thank you very much. And speaking of deployment, Leslie did show everyone here how to deploy the booster pack using the blueprint. There's also another way called the service catalog. Both of them work well to deploy the booster pack. So you can use either means of deploying it for your use. All right, that seems to be all the questions we had for today. And this brings us to the end of our webinar. So I want to thank everybody. Thank you so much for coming and attending the webinar, as well as I would like to thank Rama, Hussam, and Leslie for all the work they put into building out this booster pack for the community and for their presentation today.
Thank you, Tom.
Thank you, everyone.
It was great working with all the Canary team, actually. It was very nice.
I'd like to make an addition.
Fantastic. Thank you again.
Sorry. So I'd like to make a statement. It's that ESI is going to give us support for the participants, those who want to kind of play around with our booster pack. So we are still available to offer that support. And if you have any questions, please do not hesitate to send them, and we'll be glad to answer them.
Perfect. Thank you for mentioning that, Leslie. As yes, the ESI team will be here to help support your use of this booster pack. So please feel free to go ahead and give it a try. All right. Well, that's all for today. Thank you so much, everybody, and have a great rest of your day. We'll see you later. Bye.
Thanks. Bye.
Thank you, everyone.